So welcome students. In this video, let us look at distance formula. That is, how do we find the distance between two given points? For example, if you take the point P, let us say that the coordinates of point P are x1 and y1 and the coordinates of Q are x2 and y2. Suppose that these two are given. That means all the four numbers are given. So can you find the distance between these 2 points? So as you can see, let me plot these 2 points on the coordinate system. So how do we find the distance d between these 2 points? So whenever you need to find distance, the most straightforward method is to see whether you can form a right angle triangle or not. So you can form infinite right angle triangles about this hypotenuse, but I'll draw a right angle triangle whose sides are oriented around the x and y axis. So the construction is that I draw a right angle triangle whose sides are along x axis and y axis. That is, this is parallel to x axis, this is parallel to y axis. So let us say that the foot of the perpendicular of P on x-axis is M. Let us say that the foot of the perpendicular from Q on x-axis be N. And let us say that the foot of the perpendicular of P onto Qn is R. So now this is the construction that we do. Now as you can see, triangle PQR is a right angle triangle. So triangle PQR is a right triangle. Hence, D square can be written as PR square plus QR square. Right? D square can be written as PR square plus QR square. Now the question is, what is the lengths PR and QR? Can I find them in terms of the given coordinates? Yes. Now as you can see, what is OM? OM is nothing but the distance of P from y-axis, which is the x1. And what is ON? ON is nothing but the distance of point Q from y-axis, which is x2. So what is MN? MN is x2 minus x1. This is x2, this is x1. So this is x2 minus x1. So if this is x2 minus x1, PR is also equal to x2 minus x1, right? Now similarly, so what is this distance PM? PM is nothing but y1, right? That is the distance of point P from x-axis. So if this is y1, Rn is also equal to y1. Now, what is the distance Qn? Qn is equal to y2. That is the distance of Q from x-axis. This is y2. Now this is y2, this is y1. So RQ is y2 minus y1, right? So this is x2 minus x1. This is y2 minus y1. So d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. That is the difference between the x coordinates whole square plus difference between the y coordinates whole square. So d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. This implies d is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is a very important formula and the most basic formula in your coordinate geometry. How do you find the distance between 2 points? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. And in a special case, if one of the point becomes origin. So if distance of point P x comma y from origin is a special case instead of the second point, you want the distance of P from origin is equal to D is equal to root of, obviously we know that the coordinates of origin are 0, 0. So one of the coordinates will become 0, 0. The other coordinate we have set it as x, y. So x minus 0, which is x, y minus 0, which is y. So square root of x square plus y square. So these are the two formulas which you need to remember. So if you have two different points, root of x2 minus x1 whole square plus y2 minus y1 whole square. And if you have one given point and the other point as origin, the distance is root of x square plus y square directly. So this is how you find the distance between the coordinates if the coordinates are given in a rectangular Cartesian system. Now you also saw that the coordinates can be given in polar coordinates or with respect to oblique axis. This formula will not be valid in those cases. So let us see how to find the distance if the coordinates are given in polar coordinates and if the axes are inclined to each other at an angle other than 90 degrees. So let us say that you're given two coordinates, 2 points P and Q, whose coordinates are given in polar coordinates. That is, let P be r1 theta 1, let Q be r2 theta 2. Now what is the meaning of r1 and theta 1? We have already seen this. So this distance OP is r1 and this angle is theta 1. And what is OQ? The length OQ is r2 and this angle is theta 2. The angle made from x-axis and up to this ray is theta 2. Now what is the angle between these two rays? So this small angle is theta 1, this complete angle is theta 2. So the angle between these two rays is obviously theta 2 minus theta 1. So theta 2 minus theta 1. Now you're asked to find the distance between P and Q. So this can be found out using cosine rule for triangles. So from cosine rule for triangles, D square will be equal to R1 square plus R2 square minus 2R1 R2 times cos of angle between these two sides. Cos of theta 2 minus theta 1. So this implies D is equal to square root of R1 square plus R2 square minus 2R1 R2 cos of theta 2 minus theta 1. So this is how you find the distance if the coordinates are given in polar system. So now instead of rectangular coordinate axis, if you have axis inclined at an angle of theta with each other, in this coordinate system if you are given 2 points x1 y1 and x2 y2, how do you find the distance between these 2 points? Again we use the same cosine rule for triangles. So as you can see, if you have 2 points PQ, instead of drawing perpendiculars now, draw lines parallel to x-axis and y-axis. So as you know, this length is nothing but y1, this whole length is nothing but y2. So if you put these points as M, N and R, so QR will be equal to y2 minus y1. Similarly, if you want PR, so as you know, this length is nothing but x1, this complete length is nothing but x2. So Mn is equal to x2 minus x1, so PR is also equal to x2 minus x1. Now as you know, if this distance is theta, this distance is also equal to theta. This distance is 180 minus theta because it's a parallelogram. So if this is 180 minus theta, this angle is also equal to 180 minus theta. So if this angle is theta, this angle will be 180 minus theta. So now using the cosine rule, d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square minus 2 times x2 minus x1 times y2 minus y1 into cos of the angle between these two sides, 180 minus theta. So this implies d is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square minus 2 times x2 minus x1 times y2 minus y1 times cos 180 minus theta, as you have learned in trigonometry, is minus cos theta. So you get an extra minus from this. So this minus will become plus cos of theta. So this will be the distance formula for oblique axis. If theta is equal to 90 degrees, cos 90 will become 0. So this term completely disappears. So you get the original distance formula. So this will be the formula which needs to be used for oblique axis. Root of x2 minus x1 whole square plus y2 minus y1 whole square plus 2 times x2 minus x1 times y2 minus y1 cos theta. So I hope you have understood all the three different systems and how to find distance between two given points. Now let us try to see where this distance formula can be used. What are the different situations in which you can use distance formula? Thank you.